Hello and welcome to the Nomenclature 3 examples video. So in this video, I'll be doing quite a few examples of compounds using our additional functional groups that we're going to talk about in this unit. So the new functional groups are the carbonyl compounds, we have in this category, we have aldehydes, and we have ketones. So both of those are considered carbonyl compounds because they have that carbonyl. Now we also have the carboxylic acids and derivatives in our list. And these do all have, or almost all, not quite all, have, most of them have the carbonyl, but they've got something else next door as well. So these are going to be distinct from the aldehydes and ketones. So they're usually described as carboxylic acids and derivatives. So obviously in this category, we have carboxylic acids. We have acid anhydrides. We have acid halides. We have amides. We have nitrile. And then we're back to aldehydes and ketones. So one of the things I should have done here is put the carbonyl compounds below the carboxylic acid and derivatives because the carbonyl compounds are lower ranked than the carboxylic acids and derivatives. So when we're looking at the ranking of the functional groups according to our handout, which I covered in the first part of this Nomenclature 3 unit, carboxylic acids are going to be the first, the top ranked, then acid anhydrides, then acid halides. Oh, I'm sorry, I left out one. We also have esters. So esters are number 3, acid halides are number 4, amides are 5, nitriles are 6, aldehydes are 7, ketones are 8, and then the ones we've already learned in Nomenclature 1 were alcohols, which are 9. Thiols we're not going to do in this one unit, so I'm not going to list those. The next one below that is going to be amine. So that's technically 11, or if you want to, you can remember that as 10. And then below that would be benzene, and then alkene, and then below alkene would be alkyne. We've also skipped imine. That's another one that I'm not going to have you guys do for this one. So just a reminder of our structure, we do have the stereochemistry, we have the we have the substituents, we have the root, we have the saturation or unsaturation, and then we have the functional group ending. And this will be only the ranked functional group. So whenever you're naming these, you have to decide which is the highest ranked functional group, and we're going to use the suffix from the handout for that part. And then anything else that's not the ranked functional group, that's not the parent chain, becomes a substituent. So here, this one's pretty straightforward. We have an alcohol, and we have a 1, 2, 3, 4 carbon atoms in our chain. We're going to start the numbering from the end with the hydroxyl group present. And then this one also does have a chirality center. So I'm going to go ahead and number my groups, and this is going to be R. So when I go do the naming, I'll have R, 3 chloro, butane, 1 all. All right, so that's an example of an alcohol. Now, of course, if we have, let's say we have an amine, and an alcohol present. The alcohol is the higher ranked of the two functional groups. So we're going to name this as an alcohol. So instead of this getting named as an amine and us using the amine suffix, we're going to use the amino prefix. So we're going to number from this direction because we want that alcohol to have the lowest number possible, but we do need to start from the end of the chain. So this will be 4-amino, pent, and 2-all. Okay, so let's actually do some now with our new ranked functional groups. I'm going to start with the aldehydes and ketones. So just a real simple example of a ketone would be something like this. Here we have 1, 2, 3, 4 carbon atoms in our chain. And since it's a ketone, we're going to use the ONE suffix. So that is the functional group suffix for ketones. And there's 4 carbon atoms here. So this would be butan 2-one. Now technically here for this particular one, we could leave the number out and just call it butanone, because there's only one way you can have butanone, because we only have 4 carbon atoms. If I were to put the carbonyl on the end, it's an aldehyde, and then it would have an AL ending instead of ONE ending. And then if I try to put it on what maybe looks to be the third carbon, if I'm counting from the right, I see that actually I would end up still numbering it as 2. So sometimes we can leave the number out. I would suggest using the number if you're not sure, so that you don't have any mistakes with that. Now, ketones also can be named by the Radicofunctional method. Or also called the functional class naming. So this can be used for relatively simple compounds. We saw it with, we can use it with alcohols. So this would be ethyl alcohol. So the format is substituent, and then a space, and then the functional group. So this gets treated like a substituent. This can be used for alcohols, for alkyl halides, for ethers, and then for ketones. I think those are the main ones that this sort of naming is used for, but there may be a few others. So here, if we look at this one and do the functional class naming, then we're going to treat this and this as a substituent. Now, technically, we're going to want to put these alphabetically. You will see these names very frequently not alphabetical. So ethyl methyl, ketone. Now we're going to have a space between each substituent and the ketone. If we had, let's say, something like this, and we had a symmetric ketone, this of course would be di-tert-butyl ketone. So the functional class naming is very simple. It's just making sure you keep it completely clean and separate from the IUPAC naming. So all of this other naming that we're doing here, this would be IUPAC right here. Okay, so let's do an example where we have an aldehyde and a ketone present. Okay, so here we have both an aldehyde and a ketone, but an aldehyde is higher ranked. So this is going to be our ranked functional group. So this means we're going to use the AL ending. And if we've hopefully already memorized our prefixes and suffixes, but if we haven't, we took our chart and we see that whenever we have a carbonyl, it's going to be an oxo substituent. So that means for aldehydes and ketones, when they're treated as substituents, they both get the oxo substituent name. So we're going to number from our highest ranked functional group to give it the lowest number possible. And so this will be 4-oxo, oops, no hyphen there, pent and al. Okay, so we'll do a few more examples with some of these other functional groups, just to show how they're put together. In particular, I definitely want to show an ester because that's a little different than the rest of them. But these are pretty straightforward as long as you know, the parts of the naming that we need to do. Okay, so let's say we have a compound like this. So we have 2 ketones, we have 1 aldehyde, and then we have, so here we have our aldehyde, we have our ketones, and then we have a carboxylic acid. So without a doubt, the highest ranked functional group present is the carboxylic acid. So we will start our numbering there to give it the lowest number possible, which in this case is a 1. I always like to draw my H's out on my aldehyde. It helps me to really see that they're an aldehyde and not a ketone. So here we basically have 3 oxo substituents. So the aldehyde is still gets the same substituent name as a ketone because it really is just a carbonyl. So that means we're going to have 3, 5, 8 trioxo, and then there are 8 carbons, so that'll be octanoic acid. So this one does have a separate, kind of last name, so to speak, with the carboxylic acids. All right, let's do some more examples with some of the different functional groups that we're working with. So if we have this one here, this one is actually has a trivial name, which is acetonitrile. We've talked before about how when we have this particular group, the methyl right next to the carbonyl, that's going to be the acetyl group. So here, even though it's not an aldehyde or a ketone or a carboxylic acid, it is a methyl group beside the nitrile. So that's where that aceto part comes in. If we're naming this as IUPAC, we're going to use that ranked functional group substituent of nitrile. And then we have 1, 2 carbon atoms here. And we go ahead and start, the numbering at the nitrile carbon. So this would be ethane nitrile. One thing I do want to point out here is I added back the E, and that's because without it, we would have ethane nitrile, which would be 2 N's directly beside each other. So just like whenever we have a di, tri, tetra, etc., prefix before our ranked functional group or whatever, we will put the E back in to make it, just a little bit easier to pronounce. Okay? Let's look at the next example. So here's another nitrile, and we do have an alcohol present, but nitrile is our ranked functional group, so this is what we're going to name the compound as. This is going to be a nitrile. And this will be our first example where the alcohol functional group, the hydroxy, hasn't been our highest ranked functional group. So it's going to get its prefix name here as a substituent. So this will be hydroxy. Notice also that we do have a carbon-carbon double bond here, and it is stereoisomeric, so we're going to need to assign E or Z to this. So this will be carbon here, H here, H here. These are opposite each other. They're on either side, so this is going to be E. All right, so we put the name together. We've got E, and then we have the hydroxy at the 1, 2, 3, 4, 5, 6 position. So at the 5 position, hydroxy. And then there's 6, so it's hex. Now it's not N because we do have that alkene. And we need to say where that alkene is. So it's at the 3 position, or it starts at the 3 position, which is what we want to use. En, now, even though, one thing I didn't mention on the last one is carboxylic acids, esters, a lot of these functional groups down to aldehydes are going to have to be on the end of the chain. Like that's just sort of how they are made and set up, and there's really not a choice. So I did not use the number here because there's only one spot it could be. So here again, I need to put the En, and then it's nitrile. Okay, if we have maybe a higher ranked functional group than nitrile, but we have a nitrile as a substituent. So here, the nitrile is a substituent. Notice that I can't do, sorry, this should be chlorine. Like I can't do this because now I've made 5 bonds to carbon. So that's not a possibility. So if you're taking a name and putting in a nitrile substituent on, know that, it's got to kind of be coming off of the chain like this. So when this is going to be a side chain like this, it's going to be a substituent, and it's going to be the cyano. So we'll have to start here because the acid halide is the higher ranked functional group. Now here we do need to be specific that it's the chloride. And we use the OYL ending. Okay. So this will be 5 cyano. And I keep going with 6, but hopefully you know all your roots, so it wouldn't throw you off if you had a different number. Hex, and then I don't have any carbon-carbon pi bonds, so that'll be AN, and then hexanoyl chloride. Okay, so that's how we would name an acid halide. Okay, so let's do, we'll work our way kind of up now. Let's do an amide. So if we have like a very simple amide like this, then it's nice because it's just a primary amide and we just have the 2 hydrogen atoms here. So we'll number starting from the carbonyl carbon on the amide. And so this would just be oct and amide. Okay. Now let's say we start to decorate this guy a little bit more. All right, so let's say we have something like this instead. So again, 1, 2, 3, 4, 5. But we need to say what's going on here. We need to talk about where these are. So we're going to use the locant in for this. And we have a methyl, we have an ethyl, and we have a nitro. Okay, so ethyl will become first alphabetically, then methyl, then nitro. And so it'll be N ethyl, N methyl, 3 nitro. And then I'm going to go to the next line. Oh, I might have enough room here. I'll try it. So this will be pentan amide. Okay, and just make sure you're keeping amide and amine separate because those are going to be pretty different. All right, the next one we're going to talk about is esters. And esters are weird. I guess they're kind of like our amides with carbon groups on them. But the difference is, you know, we can only have one carbon group coming off of the oxygen. So what we tend to do with this is we'll still name this part coming off of the ester oxygen as a substituent. And we're going to put it out in the front, but we're going to separate it with a space. So this particular one, if we're naming it IUPAC, the main chain would be over here. And this would be true even if we had like a longer chain here, typically. So we have 2, so that'll be eth, N, O8. And then we have to put the ethyl out in front again with a space in between the substituent and the other part. The idea is if we were to have the carboxylate anion of this, this would be the ethanoate anion. Okay, and so it has that, well, sorry, I increased the chain length. So let's fix that. Okay, so let's do an ester that's a little more complicated than the one we just looked at. Okay, so the group attached here is going to be an isopropyl. We could give it a complex substituent name of 1-methyl ethyl. So if you prefer that over the complex substituent naming or the branch substituent names, that's totally fine. Okay, here we have 5 carbon atoms. So this would be isopropyl space pentan O8. I do want to mention that up here, this specific carboxylic acid, or excuse me, the specific ester does have a common name, which is ethyl acetate. Because if we had just this is the ethanoate anion, but it's also the acetate anion is the trivial name for it that we use quite a lot. Okay, let's talk about acid anhydrides. A lot of times for these, we'll see these with common names or trivial names. I'm not going to ask you to do a ton of these, and we'll kind of stick to the simple symmetric ones. But the idea is if we were to take two equivalents of a carboxylic acid and react them together and do what we would call a dehydration reaction. We would end up with this, and then the byproduct would be water. So that's where the anhydride part of the name is. So here, the trivial name for this one would be acetic anhydride. The IUPAC for this one would be ethanoic anhydride. Because we have 1, 2. All right, so the last one I want to do is carboxylic acids, which we've actually done a couple of examples already of, but that's okay. So one that we have already seen a lot in everything we've done that you hopefully by this point should know the name of is acetic acid. That's the trivial name. The IUPAC for this one, because it's 1, 2 carbon atoms, would be ethanoic acid. If we have some more complicated ones, so let's say we've got this one right here. Now this is one that's on your list to learn. This would be acrylic acid. But if we did the IUPAC for this, it would be 1, 2, 3 carbon atoms. So that's going to be prop. And we do have that double bond here. So this would be prop, 2-ene, and then oic acid. Okay, so we've got this one, 1, 2, 3, 4, 5, 6, 7. So it's going to be hept. First comes chloro alphabetically. 4 chloro. 5 nitro. Hept and oic acid. If we have some of our more slightly higher ranked functional groups present, we still have the carboxylic acid as the highest ranked functional group. One, 2, 3, 4, 5. So hydroxy and oxo, hydroxy is going to come first alphabetically. So we'll have 3 hydroxy, 4 oxo, pentanoic acid. All right, and just make sure to practice any of these. I'll post questions from the textbook for you to practice, and then there'll be smart work as well. Have a great day.